Okay, this problem says a large rocket has a mass of 2 times 10 to the power 6 kg at takeoff. Its engine produces a thrust of 3.5 into 10 to the 7 newtons. Find its initial acceleration if it takes off vertically, and how long does it take to reach a velocity of 120 kilometers per hour straight up, assuming constant mass and thrust. Alright, so part A, you have this rocket. The thrust is a force in the upward direction, and here's the weight of the rocket. Alright, so we'll choose our axis to be in that direction, positive direction. Right, so T minus mg should equal the mass of the rocket times acceleration. So the acceleration of the rocket is T minus mg divided by m, which is T by m minus g. Alright, so the thrust of the rocket is, so the acceleration of the rocket is 3.5 times 10 to the 7 newtons divided by 2 times 10 to the 6 kg minus 9.8 meters per second squared. Okay, so this is 35 divided by 2, which is 17.5 minus 9.8 meters per second squared, which is 7.7. Okay, so that is the acceleration of the rocket at takeoff. In part B, they want you to find what is the how long does it take the rocket to reach a velocity of 120 kilometers per hour straight up, assuming constant mass and thrust. Well, the thrust can remain constant. It generally remains constant unless an engine is turned off. Of course, the mass of a rocket is rapidly decreasing, but we're going to keep things simple and assume constant mass, as the problem says. Okay, so part B, well, let's first convert the velocity. 120 kilometers per hour is 120 times 1,000 meters. A kilometer is 1,000 meters, and 1 hour is 3,600 seconds. And so this is equal to 33.3 meters per second. All right, let's add a page. Okay, now final velocity is initial velocity plus acceleration times time. Our rocket starts off at rest, so the time it takes to achieve this velocity is 33.3 meters per second divided by 7.7 meters per second squared. That was the acceleration. Yep. Okay, so alright, so the rocket is going at 120 kilometers per hour in 4.3 seconds. Okay, that finishes that.